Now I'm going to go over functions, and the reason I'm going over functions right after I went over polynomials is because they're very similar. Functions is kind of a fancy way of writing an equation. Functions are usually represented by the f of x. If you remember seeing f of x a good bit, that's what a function is. Let me give you an example. In other words, if I give you an equation, and I give you an equation that says x squared plus 6, and I tell you that I want you to plug in 4. Well, at that point, when I give you this right here, I'm turning this expression into a function. All right? This is an expression the way it is written. Okay? When I tell you to plug in something, it turns basically into this. Y is equal to x squared plus 6. And I'm going to plug in 4. Now, this is no good. This is no good because you have to write this. So the best way to write it is I've got this function, and I'm going to plug a 4 into this function. And the function is x squared plus 6. And then I take that function, and I put a set of parentheses in it, and then I plug in that 4, and then I get 16 plus 6, which is equal to 22. So I can rewrite that f of 4 is equal to 22. So this is kind of like the hay baler, okay? It's kind of like the bicycle. It's kind of like the ice machine. What does that mean, Hubert? I don't understand what you're talking about. Well, let's draw an ice machine up here, and I'll tell you what it means. You got an ice machine, and whether it's in your basement or a hotel room or whatever, or a hotel hallway or whatever, that ice machine, it has to have electricity to work, but it has to have one other thing to make ice. It has to have H2O, which is water. Okay? H2O goes into the ice machine, and what comes out? Ice. So let's talk about this. Ice is the input. Water is the input, and ice is the output. So the function is the ice machine. Okay? Now, let's disconnect the water line, and let's put a funnel into the water line, big funnel. And I pour in a 5-gallon bucket of cherry Kool-Aid. If I pour into that funnel a 5-gallon bucket of cherry Kool-Aid, I'm going to get 5 gallons of cherry what? Ice cubes. I'm going to get 5 gallons of cherry ice cubes. If I put in 10 gallons of blueberry Kool-Aid, grape, whatever, okay? If I plug in 10 gallons of grape Kool-Aid, I'm going to get 10 gallons of grape what? Ice cubes. So what can you tell me about the input of water or Kool-Aid and the output? The output, and this is, I'm going to put it in red here, the output is dependent on the what? on the input. So if the output is dependent, the input is independent. Now we know something else here too. The output is not a good word. In mathematics and academia, we have to speak fluently. So we're going to call the output, we're going to call that the range, because it has to deal with the y values. Because output is y. Input is x. But input, that's not sophisticated enough. So we're going to call the input the domain. So the domain dictates the range. It's not the other way around. Okay? So basically, a function is a fancy way of writing an equation. So you can basically say, you can go back to your pre-algebra, and you can say, okay, I've got y is equal to x plus 3, but I want to plug in 4. Well, that's not sophisticated enough. So what we do is we go f of 4 of this function is going to give us parentheses 4 plus 3, which is equal to 7. Therefore, f of 4 is equal to 7. The old way of writing it, back in your pre-algebra days, was take x and y, plug in a 4 and get 7. So what we're basically doing between operations of polynomials and functions is you're writing them a different way. Well, what do you mean, Hubert? Well, in the previous video, we did x plus 2, and we did something like, I can't remember the actual, x plus 1, and then we did x plus 2 minus x, 2x minus 3, and we did x plus 1 times x minus 3, and then we did 2x minus x over x. Okay, those were addition, subtraction, multiplication, and division. Well, now you're going to do it, that's the way you did it back in pre-algebra and algebra 1, and now you do it a little bit different. Now you do f of x is equal to x plus 2. G of x, and you can call them anything you want to, is x plus 1. Oops. And now we do f plus g of x is equal to x plus 2 plus x plus 1. And that's going to give us x plus x is 2x. And 2 plus 1 is 3. You get the same answer whether you write it fancy or you go over here and go x plus x is 2x and 2 plus 1 is 3. So the way of writing functions is just a fancier way of writing an equation, except, you know, you're putting it in different terms, or a polynomial, sorry. F of x is equal to x plus 2. G of x is equal to 2x minus 3. And f minus g of x is equal to x plus 2 minus 2x minus 3. And what's x minus 2x? Negative x. And what's 2 plus 3? 5. And if you go back to pre-algebra, you distribute that negative, That's going to be x plus 2 minus 2x plus 3. And x minus 2x is negative x, and 2 plus 3 is 5. So you get the same thing that you did back in pre-algebra. So let's do multiplication. F of x is equal to x plus 1. G of x is equal to x minus 3. And f times g of x is equal to x plus 1 times x minus 3. And here you use your FOIL method or you use your distributive law. Whichever one you want to use is fine. X squared, negative 3x plus x is negative 2x. And positive 1 minus 3 is negative 3. And these are not the same problems we did in the previous. I just made some more up. And if you did this over here using the FOIL method or the distributive law, first times first, x squared. Outside, negative 3x. Inside, positive 1x. And 3 be negative 3. And that's going to give you the same thing if you did it over here. It's going to give you the same thing. And that's how you write f times g of x. And then, of course, the last one. And I'm just going to erase. I'll give you a minute or two to pause that so you can write everything down. And I'm going to erase the bottom one. Or I'm just going to clear it. 2x minus x over x. 2x minus x over x. And over here, it's going to be f of x is equal to 2x minus x. G of x is equal to x. And we want f divided by g of x, which is equal to 2x minus x over x, which is equal to 2 minus, oh, well, I messed up. I should have made it x squared. That should be an x squared. There we go. X squared. There we go. All right, so that's going to be 2, factor out of x, 2 minus 2x minus 1 over x, and that cancels, so you're left with 2x minus 1. Same thing over here. 2x squared over x minus x over x. That cancels. You're left with x. 2x minus 1. Okay, so the 4 operations basically doesn't change. You do them whether you have an f of x and a g of x, or you do them if you're just given and they say the directions here will be simplified. That's your old terminology. Over here, it's provide or do the function, and it says f divided by g of x, and you do the function, and they give you this instead of giving you this. Okay, this basically means simplify. Now there's one other function that we use, and you probably have not seen this before. Well, there goes the fire drill. I guess I'll have to stop the video. Sorry about that. They were testing the fire system. I didn't know they were going to do that, so that scared me to death. But anyway, we're talking about composition. And this is probably something that you don't remember too much of, but it's basically composition is a form of composition of functions, is a form of substitution. Composition of functions. I don't want to say it's basic substitution because it is a little bit different. Substitution that you're familiar with is like solving systems of equations, and we cover a little bit of that in this section, this review. in this review class. We cover a little bit, but most of your solving systems of equations is going to be in the Algebra 2 review. Anyway, if I gave you y is equal to 2x plus 3, and I had a problem down here that said x plus y is equal to 6. I got two equations right here. Since this one is y, and I'll highlight this one. Since that is y, I can take that and plug it in for y. And I get x plus parentheses, and then I plug that in, and I'm going to do it in green so you know that's where it comes from. 2x plus 3, and then I solve it. X plus 2x is 3x, plus 3 is equal to 6. X is equal to 1. Okay? So you minus the 3, you get 3. Divide by 3, you get 1. And then you can take this and back substitute and get y is equal to 2 times 1 plus 3, which y is equal to 5. So these two lines, this line and this line, intersect at 1, 5. And we cover that in another part called Solving Systems of Equations. But the reason I'm bringing it up here is because I took this function, I took what y is equal to, and I substituted it in right there. Okay? That's what you're going to do with composition of functions. With composition of functions, you're going to plug and chug into whatever they tell you to plug and chug into. I'm going to give you an example. And I'm going to show you 4 different ways that they will tell you to do this example. F of x is equal to x plus 3. And g of x is equal to x squared. And here are the 4 examples that you might see on a test or a homework. A, fog. F composed of g. And the big circle there is not a multiplication symbol. That means composed of. So F composed of g means, and I'm going to highlight the F, and that F means that I'm going to rewrite F with a big set of parentheses. That's why I highlighted it green. So I'm going to rewrite F with a big set of parentheses. Parentheses plus 3. And then I'm going to highlight the g of x. I'm going to highlight it yellow because that's what I'm going to plug in. So I take my yellow pen and I plug in x squared. My final answer is x squared plus 3. So F composed of g is x squared plus 3. Now I'm going to do golf. Golf is g composed of F. G composed of F. So now I'm going to rewrite, take my handy dandy highlighter, and I'm going to highlight G because I'm going to rewrite G with a big set of parentheses. Use my green marker. Parentheses squared. And now I'm going to highlight F with the yellow marker, and I'm going to plug in x plus 3 in yellow. Oops, excuse me. X plus 3. And now I have, and I'm just going to write it in black, I have x plus 3 times x plus 3, and that's going to give us x squared plus 6x plus 9. So G composed of F is that. And as you can see, I'm either I'm substituting this into that. And I'm substituting this into that. Just like we substituted the y equation a while ago, we're substituting it and simplifying. So now what's C and D? Well, C would be FOF. F composed of F. F composed of F, but I want you to pause the video and work on these two. FOF and GOG. FOF is F composed of F, and GOG is G composed of G. So go ahead and pause the video and work on those two and see how you do. Now, I'm going to highlight that F. That means I'm going to rewrite it with a big set of parentheses. So that means x plus 3. And I'm going to take my yellow and I'm going to plug that in. So I'm going to plug in x plus 3 into itself. And now I get x plus 6. Now I'm going to take my highlighter and highlight G, because I'm going to rewrite G with a set of parentheses. So that's going to be squared. And I'm going to plug in G, because whatever's in this second spot right here, I got to plug into the green. So I'm going to plug in x squared. And using the power rule, 2 times 2 is 4. So I get x to the 4th. And that is composition of functions. And that is the 5 things that you have to remember is the 5 operations, or the 4 operations plus substitution. So the operations with polynomials feed into the composition of functions. The solving systems of equations, which you use substitution, falls into composition of functions, because you do use a form of substitution to get the composition. And that is operations with functions.